Another thing which I can do is that I can create just any shape here, like a box as example, and make sure that box is attached to the wheel surface, so it just move with it. Or even in the first frame here, I can put the box inside his mouth like this. And just try to position a box to describe what we can do. A small box, cube, or even a cylinder here. Let's move it. This area, let's just put everything in wireframe. And let's display the wheel in like this. So for the cube, we can make it smaller and just position it in this area. It doesn't matter if it will intersect with his body, as long as we have empty area, it will fill it with particles. And of course, we have to look at it from the perspective, like here. Move it here. Now, as you can see, we have local coordination. If we want to change it, we only need to press this and it will be a word axis. So then after that, what we can do is that we can add another emitter, or we can add this to the same emitter. If you go here, you find that we can choose from this list much more than one emitter. Now I will go back because we have this emitter already. And when in the first frame, it will create some particles. When the wheel will move, these particles will be here, and it goes up, start opening his mouth, the particles will start spilling from his mouth. I wanted to mention that because I think it will generate something which is really interesting. Some water coming out from this angle and this angle. Here also we will have some water around, and when we activate or when we run the foam and the splash, this would be really interesting. Now we are ready, I think, to create. I didn't continue the simulation, and I don't want to really waste our time just trying to simulate everything in this resolution, because after all, we will increase this resolution to a very big number and we will simulate everything. But for now, I'll just simulate a few frames to see what would be the result. In this stage, I think we will start adding the splash, and we will do the same technique we did with the beach project. The difference is that we will really notice the difference between the two splashes. Big splash, which is the dump splash, and the hybrido splash, which is the thin, I call it thin particle splash. Also, we'll add the foam for everything. So let's do that. We will start creating the first splash, and we can do that by going here, hybrido, and I will just create splash, not splash and foam. Remember, just splash. Let's position it right. Need to rotate it a little and scale it. This is the area which I need the splash to be, and let's use it wisely. So previously we covered everything, but in this time I don't want to cover everything. Actually, I will make it wider, but You will notice later that because we have movement here, and maybe we'll have some movement there because the whale is coming from down, from below the water, that we will have some particles here which we don't need at all, some splash and foam. So I will just increase its height first to include all the area where the whale will be jumping to, like as example here. Then I will make sure it, if I will look at it from this perspective, it's above the bottom side of this water. So I will make sure now I don't have any particles down here, splash particles. That's good. I think we are good now. And maybe I will make it wider because I don't want to clip all the particles which cannot try to go out from here and here. But the idea about it is that it will allow the particles to be created here, but it will not kill them if they will go out. What I did here, I didn't allow the particle to be created here. So it doesn't matter if I will make it like really tight or wider. The most important thing is that in the first frame, I include everything. That's it. And let's add some parameters. So here, if you remember, I will change this to hybrido. The first one is hybrido, liquid hybrido. And for this one, I will keep this 0.3 for now. And for this, I will not really change much. Actually, let's just create more. We can start with small number and increase it, but in this case, I just start with big number. For this, I will not change it. For this, maybe we'll allow it to be created from all, much more areas. As example here, when the whale will jump here, I need it to be created from here, even it's a flat area. So what I can do is that I can decrease this number, which will allow it to be created from flat areas, less curvy areas, and we describe this parameter. And for the speed, what I'm saying is that whenever I have particle faster than this amount of speed, it will create a splash, else it will not create a splash. Now I have really stormy water. I don't need to create splash from areas is fast. So I will just increase this number. Of course, again, you can just keep the numbers as they are, try to fix them. I have an idea about what would be the best to do here. Of course, we will change them. Remember, whenever I do a simulation, I just tweak the numbers a little. Anyway, we'll get the final results with the scene. You will have everything. So 0, I don't change this usually. And for this one, 2 is good. For the position, if you remember, it should be between 0.08 and 0.14. These numbers are good. So what I can do here is that I will start with 125. I will not change the angle variation. I will not really need to change it now, but I will change it for the other one, which is the dumb particles. Not now, at least later, because we will face some problems. So everything as it is here, and I will just put 4 for the minimum lifetime and 7 for the maximum lifetime, which I think are good. I don't want them to die fast, because when the whale is jumping from here to here, some of the particles would be like dripping from, down. I want them to live as much as they can. Maybe we can decrease this number later. And this would say the possibility. So it's 100% possibility for every splash which touch the water to create foam. But I don't really care much here, because I don't want to create foam from the splash. This is for the splash number 1, and I just will call it 1 here. Let's duplicate it. And for this one, what I will say is that I will call it dumb particle. And for this one, let's change the parameters. I will do dumb. For this, the same. Maybe we'll change it a little. And for the angle, actually, I need it to be really concentrated in the areas which is stormy more. But here, for this parameter, what it does say is if the angle between the surface of the water and the particles direction is less than this number, it will be created. I need more particles for this, and I need it to be created from certain flat surface. So I will increase this. Let's take the double as example, 90. For the curvature, I can just leave it as it is, or just, around this number. For the speed threshold, also we can leave it as it is. And for the verticity, the same. Neighbors, the same. Here, I think I need to decrease this number because last time we created this, we ended up with a little clustery or just clumping particles. So I need to decrease it to reduce the possibility of them accumulating over each other. And I explained this before. So whenever we increase this number, we will have areas of particles. So I will say 0.08 is enough. And I will leave everything else as it is. For the timing here, I'll just leave it the same as the splash one. Now, else, let's create the foam. And the foam is the same. I just press foam and I will have it. Let's just call it 1. And for the foam, not much really. 1000 for the density. It's water. I don't want to create it from splash. I don't want to create it from bubbles. There's no bubbles. So the only place I want to create foam from is the domain. And let's change the rate. I want bigger number. 200,000 is good. The angle is good. I think it's good. Something around this is good, but I need to reduce it a little because as you saw in the beach example, we have the foam covering everything. Now I did something here. If you remember, I put 14 for the verticity, 14 point something, just to make sure that we have some swirls, and we have really a good amount of displacement here or waves, which gonna really give interesting shape for the foam because the foam is attached to the surface of the water anyway. So that's good. And for the curvature, also I don't want it to be in the flat areas. So I will decrease this number. And for the speed threshold, also maybe we'll keep it the same, around the number, around 2. We will see, and we'll change according to the results. No change here, no change here. And for the position, again, whenever you increase this number, you will have really clumpy and just accumulated particles. It doesn't appear really much in the foam, but we notice that in the areas which has really sharp edges. So I will decrease this to really small number, and if we will face any problem, we will increase this number. Also, I can say 3 and let's say 5. That's good. Remember, we have some lines here, the stringiness, when we did the beach example. What I can do is to reduce this. I can reduce this number, let's say 0.7, and I think this number is good. Now, what I will do is that I will run the simulation and I will come back when I have some results to start from there tweaking things and changing whatever I want. Now we finished a few frames. Let's see what we will have. So I'll jump to this frame 13. I'm displaying everything. Already we have something. So let's just hide everything and just display the splash one. Not much. How much splash we have? Already we have 18,000, which is not much at all. We can increase this number, but if you notice, we have really nice pattern here. I will hide the domain itself. This is the splash. Now this is so nice because now again they will be attached to the surface of the water. In here in this frame, we will have something coming out from the wing. Again, when we have more particles, we will have something coming from here. So let's remember the C with the C and without the C. That's nice. Let's go here. And this is good. We have the lines now, but we have some accumulated particles. I wouldn't mind that, but sometimes you need to decrease this number to make sure that you don't have areas which has more particles and areas which is empty, which is, I call it clustering. And let's display the DOM. Notice this, and because they are basically the same, duplicated from each other, we will have the same shape, but it's much more fuzzy because dump is fuzzy. Look at this. So we have really nice presentation for the particles here. Now, what is interesting is that I don't have particles from the sea here at all. Like if I will hide these, I don't have anything here, but I have these because now these are attached to the body. Means even if the whale will move, it will not be empty totally from the water. This will be dripping all the way until it's just above here, and we'll have some drops. Then when it collide with the water, it will be created again. So that's so interesting and this nice. Also, that will give us an idea about creating the foam. Whenever any of these will touch the ground here or the surface of the water, it will convert into foam. Only if we activate on the foam this one. I'm not activating this one now, and just you can try that. But the idea about the foam is that the foam will be really a lot here and filling everything. So I really don't think we will notice it from this height. If you remember, our camera is like this almost. Let's display the foam itself. I will hide everything and I will just display the foam. The foam is much, and if you read the number here, we have 3 millions. It's more than the water body, and this is what I expect, because when you start rendering things, just go close, and you will understand what I'm talking about. Here we have less lines than we had before, and at the same time, when we render, these are the areas which can appear. All these areas will barely will see them. And also another thing, we will add displacement after all for the domain. Now you will see everything because the displacement is not there. But after we added displacement, some of these particles will be under the water. except if we will run snap form to the mesh sequence. They will come up, all of them. But the idea here is that why running this? Sometimes if I'm just above everything, I will just render them alone and render the surface of the water alone and just composite them over each other. This will be over and this will be down. So I don't need really to run this from this angle. If I have a sea like this or my camera is like this, I would do that. I will create this and I will make them, push them to be over the displacement. But for now, I don't need to add anything. This is it. And if you see in the first frame or the beginning of the animation, I have no particles almost from the foam because I didn't allow it to be created very fast. Anyway, when we go the animation, they will be created gradually until we will have everything there. What we can do to make sure that we have more particles, more foam particles, is that we can save the state, their state here, like we did with the sea. And as initial state, whenever we run the simulation, they will be in the first frame. Again, I will not do that. You can do that by your own. But for now, I will do one thing. I will increase the resolution of the main water body because this is nothing. Let's see here. We have almost 2.2 or 0.3. I would expect 14, 15 millions is a good number to start with. Usually for these scenes, I would go to 25, 30 million particles. And based on that, the foam will be like 20 to 30 millions. The splash and the splash pump will be around these numbers, maybe half, something like that. But the total amount of particles will cross the 40 millions. Then when you render, you will find everything with the full details. So what we will do now is that I will go here to the main domain particles, and I will do one thing. I will decrease the resolution to 0.0, let's say 7, and I will simulate everything again. Then I will come back, of course, including the foam and splash. But again, to mention something before I just jump to the simulation, important thing is that, which I didn't mention here, I didn't think I need to mention it here, but when you simulate, we first simulated the domain. These weren't here. We didn't have these. Then what I did is that I moved this into cache mode. Also here into cache mode. I don't need to do that, but I'm doing that just to clarify everything. Then I created the splash one. After I finished, so it was green. After I finished from this thing, I just made it red. Or I can just put it on the cache mode because I don't really want to calculate it again. Then I simulated this one. Then I moved it into cache mode. Then I simulated this one because it will be created from all these. Then I move it to cache mode. So everything now in cache mode, and if I will move my time slider, I will see everything as I supposed to see it. This is how I create everything faster. If I will do the opposite, if I will just go and choose everything here and green, if I will put everything active and start simulating everything together, it will be more interactive actually, but you will not notice that much, and it will be really heavy because it will take a huge amount of time to calculate this interaction. So this is stable more, and you can really discuss everything. So you can create this, reshape it, maybe change some parameters until you get the ideal motion you need. Then you can jump to this one, create exactly what you want. This one will be the same, and this one is a result of everything else. That's the best way to do things. So, and also when I run this, I usually don't run the ocean force because it shouldn't affect everything here. It should just affect the main domain. I will increase the resolution I mentioned here. Then I will simulate everything and I will come back again after I finish. Now I am done with the simulation and we have this result. But of course, I can do other variation, other trial and get more or different results. But let's see what we did. So before I start talking about the results, I did some grouping just to put everything together in a smaller space and just to be able to control everything in a better way. So now our project is small, it's not that big, but when we have really more complicated setup, it's always good to organize everything. So what I did is that I group some of these things. So here in asset, I put the fish group and I put the plan, which we don't use actually. And if I would press here, this is it. So it's closed. If I double click it, I will have all the elements inside it. Just for some reason it's just here, so they are far here, but for now I don't need to do anything, just double click it and it will be closed. I did again the same for the whale, so I have the group again and I can select individually anything of those. Also I did that for the domain. So the domain is, I made this node which is just a helper, and under this node I put the domain water, which we used for the to create the water inside for the emitter, and we have the emitter here and we have the domain here. So usually the domain comes under the water. I don't need to change that, this is how everything should be. But again, this is the setup and it's just easy to organize everything. The idea about this is that I include everything related to the domain under this thing. Actually, I can rescale it and scale everything together. And this is how the closed domain is working. And when you create something with the closed domain, actually it will be named like domain. So this is how I created this thing. And also I did something. I did started the simulation with the numbers I mentioned for the domain, which was 0.07, and the amount of particles was huge. Now we have 14 millions point something. It was almost 45 millions, which I don't really need in this situation. So I just increased the number to 0.12, which was really good. Other than that, nothing, just small changes here and there. I actually didn't change much. For the foam, I decreased the number of the foam to 195,000 here, and I changed some of the parameters here, but not much. Again, I try to keep everything 0.03 the same, nothing changed here. For the splash, I decreased the cell size, means I increased the resolution, so I have more particles, 70 instead of 30. I wanted to increase this number because it was really not much and I needed to draw these lines. And other than that, I allowed the splash to be created from wider area based on the angle. Here also for the curvature, changes a little. And for verticity, I just introduce 0.02 more than it was 0.0, and it just didn't really affect anything, but was trying to do something. For the position variation, I went to 0.11. That was a good number. For the angle variation, I kept it as it is, and I reduced their age, because if we will jump from here to here, it's 2 seconds, almost to 93 seconds, because if you will go here to options, you will find that the frame per second is 30, so every 30 frames are 1 second. So the whale jumps here, and actually the particle lives long enough, so I don't need really to increase this number for more than this. For the DOM, I increase this number dramatically. I have 10 millions to create the amount of DOM particles I need. And the idea about this is that it should be like a cloud of particles, so I need really huge amount of particles. Also, I didn't create it from every place. All I did here is that I made it just where you can create these particles from the tip of the waves. Increasing these numbers means I need really big velocity or speed value for the particles to be able to create the DOM particle. That's here. The curvature, I don't want to create these DOM particles from here, flat areas. I need it to be really curvy, like the tip of the wave. Here again, I introduced the same number. For the position variation, I didn't change it. And I did one thing, which is, I think, one of the most important thing here, is that if you go here, when you increase the number of particles for DOM particles, and I will stop almost here and 210, just let's start. It will take time and to load, because I'm loading everything from external drive. The amount of simulation, it's almost 1 tera and 800 meg almost, which is a big amount of memory. So I did that in external hard drive, and it takes some time to load. But anyway, here for these numbers, I notice when we do, I'll try to wait a little. When we increase the number of splash DOM particles, we notice that we have some kind of pattern which I didn't like. If you notice here, we have lines. I will wait until it just... Yes. Now look at these lines. Multiply this by 10. It was really clear. In the animation, in the movement, you will not notice this really, and everything with motion blur, you will find everything cool and there's no problem. But look at it now and just analyze it. Let's analyze this. So basically what we have now is that it's fast and it doesn't have ability to be moving differently from each other. So it has one certain angle, and they were really limited in their angle before I changed this. And they have like, they express that they spread it in a certain direction with the same speed. So what I needed is to change the velocity here from 0.1 to 1.2, allowing them to move freely, different speed or different velocities than each other. This is what happened. So I got more fuzzy scenes, which I like really much. This is my target from creating another splash. And the other thing is that I decreased the angle variation. If you will go here, it was 10. Now it's 8. Means I don't want them to have really wide curve, smaller curve, which produce nice particles. This is what I have. And for the foam, again, For the stringness, I noticed that I need to have these lines. It's just forming something nice. So I increase this number. I reduce. I just kept the lifetime for them. And for the friction, again, the friction means that they will stick with the surface of the water when it's moving. This is what I did. I didn't change this much. So this is the result. And let's see. This is at the end of the simulation when everything is exploding because the whale jumped into the water, and we can see it's so nice. Let's display all the particles to see what's happening. For the foam, it's filling everything. It looks like it's just a lot, but it's not actually a lot, because if you go close and close, these areas will be almost not noticeable when we render. Only the very dense area will be noticeable. The amount of particles here, for the foam, it's 40 millions also. It's like almost as much as the main body particles. And we can see them in other frame, but let's see the fuzzy, which is the dumb splash. Look at it. It's just cloudy, and it's so nice because when we render everything, and it's 7 millions, when we render everything, it will look like a mist. We can, of course, create a mist, but this will produce something between the drop of waters and mist, while mist is just cloud, which also we will render using clouds, a volumetric renderer. So it will not give us the dots. So if you look at this, let's look at the splash. So we have these lines, the splash build up above these lines, and it's concentrated, but the dump above, exactly above them, but it's really fuzzy. This is the idea. Now, all the particles around here, I don't care about. I can trim them, of course, here by putting, let's get this down, by introducing kill volume. But I don't need to do that because I can trim them using the BRT loader later in 3D Max, or I can just ignore them because my camera is like this. But for calculations, I can kill them. I needed the water to come out of the space here because if I will clip it from here, it will look like it disappeared suddenly. So this is nice. Let's jump to the first frames because I think these are the frames which we need to see how the whale is moving. Let's look at it now. And it looks really nice because one by one, the foam is here and it's just really covering. I didn't start from initial state, so it's just starting from here, but it's nice. If you look at it from this angle, we have the main domain. Let's hide everything. The main domain is dense, and we have really nice splash already. We can move to 45 when it's just above the water and see how much it will carry amount of water with it when it's moving. Remember, we introduced some kind of friction which gonna help it to carry the water above, and also I did some increasement for the sampling, as I remember. Here it's 1 by 1. Actually, I did 2 by 2, just to take in consideration. Look at here now. Now it's carrying all the water above the surface of the water, and it's so nice. This is what I expect from here and here. Also here it will be really forming very nice wave. So again, the water is sticking here, but it will be sliding when we move. Let's display the splash. The splash is doing what it should do. It's just spreading everywhere. The pattern, how it's moving, is nice. I saw in other programs like Phonics FT, really interesting pattern, much more than this one, which told me that we need to introduce more noise for this for the splash, which I can do by just introducing noise. Sorry, here in diamonds, we can go to noise field, or we can introduce wind, which already have some noise, which can really form something more interesting than this. But this is so nice. If you look at it from above, it's so chaotic, and it's exactly what we expect to see. Some of these lines are so like behaving with a character. They have a character, which I like. And also, if you will display the dumb particles, it's covering everything. It looks like it's covering everything, but actually it's not. All these details, when you go here, this is not so dense. When we render, it will not be so dense. And if you will see how much they are 4 millions, which is good, but not that much. So let's continue and display all of them. Now, as you can see, I can see some of the underlying splash. And for the foam, I can see the foam also. Let's jump to this frame as example 70 to see how much of these particles will be carried out with whale movement. I'm not doing some review or anything because it will take time more than rendering the result. So because of that, I will depend on the final result. You will see that in 3D. You will see with the render. So no need to do something here. For you, it's really important to do something here. I would recommend that because it will show you how everything is happening. And you can do that just by going to playback and OpenGL, create some video. But again, if I will go to preferences, make sure you drop this number to 720 or something. You don't need to create that in HD. And creating a review through OpenGL, it takes time more than rendering these particles with the Krakatoa. Imagine that. So that's why I don't really tend to do the preview, especially when it's not my time, it's your time. I'm consuming your time. So if you look at it, it's so chaotic, and it's exactly what I want to see. If we look at it from any angle, it's so interesting. And this kind of fuzziness is the thing which I meant by creating the dumb particles. This is exactly what I think gonna sell the shot. Until now, we can see that the whale is covered by water. It's covered by mist. It's covered by splash and some white particles. And this is what we should see when a whale come out of the water. Again, if we put some water here, as I mentioned with the cube, small cube, we will have some water dripping from all around it. And two other things. One of them is the wet, which can produce some lines. Also, I don't have enough geometry. As you can see, I didn't really increase the resolution for the collision object, so I don't have the lines here. Usually the whale have lines here. For our model, it's just not there. So if I will put these lines and I will increase the resolution or decrease the cell size for this whale, I will start seeing these lines. So all I need to do is to decrease this to 0.0, like 4 or 3. It will be costly when we do the simulation, but we will see some lines, some water between these. And if we will have wet, it will show more. Also, another thing is that when we render everything, usually the material which we'll apply here, it can have glossiness because it was under the water to show us that it was wet. When it goes out of the water, this glossiness will be reduced based on how much is touch the water or out of the water. This will be produced usually with a wet map. And if you go here, you can see that the wet map is here. If I will activate it, it will not really produce the wet map here. The way to do that is to use the Diverso to create this wet map. We introduce these particles through Diverso, so we will consider Diverso as a generator of these particles. And we don't have to reproduce them again, it will be the container. And in Diverso, it's easy to create this material. Maybe we'll have the time to go through that, but there is some small tutorials in the internet produced by Next Limit about this operation, which is so easy to do. But that will give us also sense that there's water all around the well. Let's jump to another frame. In this frame, we should have no water attached to the well, only these white particles, some of them at the tail. It takes time usually, but not that much because again, I'm having all the information from my hard. Remember that we will mesh everything now, and when we create the mesh, it will be a huge amount of faces, and that will increase also the memory. So we need to account for that before we start working. Now we have some particles, as you can see in the tail, because the tail is the last area which was touching the sea. And again, we have all these lines and fuzzy particles and foam everywhere. So that's it for the jump up. And when it goes down, it just do a big splash. I can reduce the splash by going to the well here and try to reduce this number. Again, what I did is that I animated this number from 0.05 to 0.055 at the end, and this number from 1.1 to 1 at the end, because I don't want it to really interact much with the water body. Look here, I don't have any particle here on the well, except few particles here. So now when it collides with the water, let's see here, we will have everything like exploding, and this is exactly what we expect. Again, next step will be creating the displacement for this surface. And as you remember, we used the real wave surface. This is what we'll use again here. And we will follow the same procedure we did previously to apply all these displacement to the mesh itself. So now I have everything covered. And if I want to see the particles, I can just kill them one by one. This is the main body of water. This is the foam everywhere. And this is the thin particles, or we can say a thin splash. And this is the fuzzy one, which can render very shallow, and it will give us the sense that there is some kind of volumetric sense of particles when they jump from being really concentrated to almost disappeared and merged with the air. So that's it for now. And what I will do now next is that I will start working on the meshing and the displacement. Before we do the meshing, one thing which I should mention before we do the simulation, we should study the wave. I mentioned that before, but I actually did that. So before you increase the resolution and do anything, you should study what kind of values you should apply here for the displacement. then you do the simulation. So you store all the information inside the mesh. Of course, you don't have to do that because you can get this information after the simulation, but it's just to make sure that everything is going right and smoothly. Sometimes you will have some bugs if you don't do it that way. So before the simulation, calculate the displacement values. So to do the displacement, we can do two things. First, let's create a mesh, and also let's create a real wave surface and start putting some parameters. I would say let's create the real wave surface, then we create the mesh and apply the same parameters for the domain, which I did, but just to show you how the process is happening. So the first thing is that I will go to real wave and I will create one surface. Let's wait a little. Now I have the surface. Let's go back. Let's move it here. And remember, the scale of this surface should be almost the same as our domain. So let's increase these numbers, or just have here. Let's have some like 24 as example, just to cover the area of this liquid. Actually, it should be exactly like the domain. So let's increase it. Let's put 30. And let's put length. Maybe I have some dimensions here which I can use. Not actually, it's not giving me this the size. So here I can say 65, and it's almost right. That's it. I don't need to move it or do anything else. Now let's start creating some values. So I will hide the domain by going here and hide. And also I don't need to have the domain loaded whenever I move the timeline. I will talk about exporting now, but let's just get some values. So the resolution is good, but I don't think it's enough. We may increase the resolution ongoing. So the first thing, let's press 9 on the keyboard to have smooth shaded presentation for the real wave. And let's jump here. We know that we have a polygon size of 0.1. Maybe we'll decrease that later. And second thing is that I right mouse button and I can introduce wave, which is ocean statistical spectrum. We went through that before, but let's go again and put some values. If you remember from the beach example, we have some numbers, and I will try to benefit from these numbers. So for the time factor, I have 1. Remember, it should work in real time. Although we changed that in the ocean into a really big number, it doesn't really match. So here I noticed that we have to go real time. So it's just 1 for the time, and for the resolution, it's meant to produce really detailed displacement. So because of that, I'll increase it to 512, not like the ocean forces, which is just to get us or to bring us some big waves. Now we can go to the depth, and if you remember, for the depth, it doesn't mean much for the, except if it's from the same category as the main length, wavelength. So because of that, I will just put it as example 200 as I put it before. And we can go down to see this factor, sorry. Yes, this one, which is the most important one. And I would say a value of between 0 and 10 is good, but let's just reset everything and see what what we will have, I don't know, it's because everything is loaded on the hard, external hard, that's why we have some delay. But yeah, that's good. Let's see. There's no, I can't see anything actually. What I can do is that I can increase this number to, let's say 2, which is big number. And let's see what's gonna happen. It's huge. It's a disaster. What we can do is, instead of decreasing this one, we can decrease this number. Let's see the relationship between the two. 25. And we saw that before, but just let's discover it now with the new mesh. I have to reset. I think we have much more interesting wave now. It's a small still. I can increase this, let's say 10. And next we will try to, yeah, that's good. That's good. Of course, we can decrease it less than this on the ocean itself, but we have something, we can see something now. We need more resolution, of course, but let's start changing some of the values. For the wind speed, I don't need it to be really fast because it's meant to produce the details on the surface of the water. So I don't need 30. I would say 5 is enough. And let's see if that will affect the shape of the water a little. So also the direction, the wind direction, if you remember, if I will do small number, for the direction is 45. I need it to be a little different, less than that, to have something which is not the same direction. Let's say 10. And let's see here. Also for the alignment, yeah, it's more regular, but it's just, it looks random. It's good. For the wind alignment, I will leave this number as it is. Remember, if we will increase this number to 30, what's gonna happen is that it will be so regular. But all the purpose of having this kind of displacement is to introduce some more chaotic or random displacement, which is smaller and everywhere, not like this. This was produced using the ocean's forces. We don't have to do it again. So the min wavelength, this number can go smaller. Let's see the difference now. If I will go 0.02, I should have more details now, at least here. If I don't notice these details, I need to reduce the polygon size of this mesh, but I really notice it. And I think it's really cool. We need more of these, but we will just depend on repeat U and V to produce more of these. Now for the wind against the weight against wind, I will leave this as it is because it's always good to have it in the middle. For the chubbiness, I can say 0.8 is good. If we increase this number to 2 as example, you will find, or you see some intersection between the tips here. Look at this. It's more clear, but it's just intersecting, which we don't need to see this at all. So 0.8 is good, and maybe we can reduce that more later. And for the U and V, let's change it and reset again because every time it takes time. So I'll just leave this 1 and 4 because this is longer, so I will just do that. And now we'll have really something interesting. Look at it. There is some kind of pattern, clear one, but again, it will not show with all the other waves. So we can break this pattern. Actually, we can just even increase it first. And of course, I need to decrease the vertical scale because it's just really much now. This is nice because I broke the pattern now, and I can go to scale and reduce it to 2. Because this amount of displacement is almost the same amount we have here for the ocean forces, which is really much. I don't need that much. So I can just decrease this number or increase it to 5 to have something in the middle ground. And remember, this is the only number which is not transferred exactly to the final domain. We should decrease it by 10 times or 100 times. So I will just commit to like 10 times less than this number. So now we have something really nice. I will keep this. First, I don't really need to keep it here in the file, but I will keep it for you to go through it and see what numbers we have, but I don't need it really. Also, for the movement, I can just simulate and see the movement, but because I know the numbers now, and if you remember here, the direction tells us that it will move exactly like the other waves, the other ocean forces. So I will not simulate anything now. I will just leave it as it is, and I will deactivate it. Let's hide it, and let's go and see the domain. Remember, this step, what I'm doing now, it should be done before we do the simulation.